So very good morning. So previously we have been learned about till 6 problems we have been learned. Let us know about the further problems. So the given problem is show that the relation R in the set A 1, 2, 3, 4, 5 given by the R is equal to has whatever the condition you deduct, it should give the value as even number is an equivalence relation. This is the first condition you need to prove. Next, show that all the elements of 1, 3, 5, 1 are related to each other. You have to show the set 1, 3, 5 are related to each other. All the elements of 2, 4 are related to each other, but no elements of 1, 3, 5 are related to any element of 2, 4. So, nearly you have 3 conditions to prove here. First one is equivalence relation. Second one is you need to prove 1, 3, 5 are related to each other. And third condition is 2 and 4 are related to each other. And the last one is you need to show that 1, 3, 5 are related to 1, 2, 4. That is you need to make a proofing wise. So let us solve the first condition, that is all the elements of the given set are equivalence relation. So before knowing the equivalence relation, so you need to know that all the 3 conditions should be satisfied. For the given set A 1, 2, 3, 4, 5, what is the relation they have been given? A minus B, mod of A minus B should be equal to the even element. Means what? Whatever the elements you deduct with the given set A, it should produce an even element. So even means you know that is divisible by 2. So according to this condition, so what are the elements will be there? Let us check. So if I take for the given condition 1 minus 2 is an even? No. So 1 minus 1, that is set of all reflexive, it is possible. That is 1 comma 1 will come, 2 comma 2, 3 comma 3, again 4 comma 4, again 5 comma 5 can appear. Next, which are the elements is there? Let us check. If I deduct 1 minus 2, so it is an odd. Next, go for 1 minus 3, it is possible. 1 minus 4, it is not. Again, go for 1 minus 5, it is possible. So 1 minus 5 will give the value 4. Minus 4, after putting the mod, it will give in a positive values. Again, let us go for 2 minus 1, no. 2 minus 3, no. 2 comma 4, yes. 2 comma 4 is possible. 2 comma 5, no. Again, 3 minus 1, yes. 3 comma 1 is possible. Again, 3 minus 2, no. 3 minus 3 is possible. 3 comma 4 is not. Again, 3 comma 5 is possible. Again, 4 comma 1. So 4 comma 4 minus 1 is 3. Again 4 minus 2. Yes. 4 comma 2 is possible. Again 4 minus 3. No. 4 minus 4 is possible. 4 minus 5 is not possible. Let us go for the next. Last one. 5 minus 1. It is possible. That is when 5 comma 1 is possible. 5 minus 2 is not. 5 minus 3 is possible. That is 5 comma 3 is possible. Is it possible for 5 minus 4? No. So these are the Cartesian products. These are the relations that are related to the even elements, right? So from in this condition, we need to show it is a reflexive, transitive and symmetric. So as you know, what does the reflexive function says? So reflexive function always says that every values of it should has its own reflection. That is A comma A should belongs to A for every A belongs to A. This is only possible. So 1 comma 2, 1 comma 1 is present, 2 comma 2 is present, 3 comma 3, 4 comma 4, every element is present. That is 1 comma 1 belongs to A, hence it is reflexive. Hence it is reflexive. Next, what does the second says? Symmetric condition. So what does the symmetric says? Symmetric says that if A comma B belongs to R means obviously B comma A also belongs to R. So what is the condition? A comma B belongs to R. So what is the value of, let us take some values of random 4 comma 2. So let us take 4 comma 2 is belonging to R is possible. Now you need to check for B comma A is belonging to R or not. B is 2. 2 comma 4 is possible. Is there any presence of 2 comma 4? Yes, here is that. Right. So therefore 2 comma 4 also belongs to R. Hence it is symmetric. So for every condition, for every problem, it is compulsory to write the conditions. So according to this, let us prove the last one, that is transitive. So what does the transitive function says? Transitive says that if A comma B belongs to R means obviously B comma C should be linked. So if I take the previous one, that is 4 comma 2, or you can take it as 1 comma 3 is belonging to R. So according to the R relation, 1 comma 3 is there? Yes. Is this 3 is linked with any kind of elements? Yes, it is linked with 3 comma 5, 3 comma 1. So as you know, 1 comma 3 is symmetric with 3 comma 1. We cannot take that. So let us take some another value, that is 3 comma 5. So according to this, 3 comma 5 also that is belonging. B comma C is belonging to R. Hence 3 comma 5 also belongs to R. If B comma C is belonging to R means A comma C also should belongs to R. What is the value of A is 1 and what is the value of C is 5. Let us see. Is 1 comma 5 is present? Yes, as you know, 1 comma 5 is present because according to the given condition, it satisfies the relation R. Therefore, 1 comma 5 also belongs to R. Hence it is symmetric. Hence it is transitive. So if all the 3 conditions satisfy means hence it is equivalence. Hence it is equivalence relation. Hence it is equivalence relation. Next, let us go. What is the second problem you need to solve here? So according to the given condition, you need to show that is all the elements of 1, 3, 5 are related. Yes, obviously when I put 1 minus 3 means it is giving the value 2. Again if I put 1 minus 5 means it is giving the value 4. Now let us check for 3 minus 1, 2, 3 minus 5 is again 2. Again 5 minus 1 is 4, 5 minus 3 is 2. Obviously each and every elements are related to each other. That is therefore 1, 3, 5 are related to each other, because of odd number after subtraction. After subtracting, it gives what kind of element? It gives even element. It gives even number. In the same way, you need to check for 2 comma 4. Is it possible? Obviously. So therefore, these are related. These are related elements. So in one questions you have four conditions. In that 3 conditions are solved. In the same way, the last condition you check. So according to this, you need to check with 1, 3, 5 is related to 2 comma 4. If both the elements are giving the same even number means, hence if I deduct these 2 elements also should give the same even number. Is that possible? If I deduct 1 minus 2 means what is the element? 1 is getting. If I deduct 1 minus 4 means again 3 will come. If I deduct 3 minus 2 means 1. 3 minus 4 means again 1. Again 5 minus 2 is 3. Again 5 minus 4 is 1. So however the element you deduct with the given relation R, it is giving an odd number. It is giving an odd number. So this is not related. Therefore it is not related. It is not related. Done. This finished the first problem. So let us go for the next one. So what does it say the next one? So whatever the elements you want to prove, make sure that you need to know about the condition. So without knowing the condition, you cannot solve any kind of problems. So what is the first condition says that? Show that the relation R in the set A is equal to X belongs to Z such that 0 is less than X is less than 12 is given by. You need to prove for two conditions here. Means for the given set you need to how the relations are related to each other. So according to this, let us solve the first one and solve the second by yourself. So what is the first one says here? First one, R is equal to A comma B such that mod of A minus B is equal to multiple of 4 is a multiple of 4. This is the relation they have been given. First, find the set. So what is the set A carries? Set A carries the element of 0 to 12. Even though it is belonging to the integer, where does the X lie? X is lying between 0 to 12. So what are the elements will be there then in A set? 1, 2, 3, 4, 5 up to so on. 12 elements will be there. So now according to this, whatever the elements you give, it should be a multiple of 4. If I take 0 minus 0 means obviously it will give the value 0. It is a multiple of 4. So therefore according to the reflexive, we know that 0 comma 0 belongs to R. Therefore A comma A which belongs to R, hence it is reflexive. Next, in the same thing you need to prove for symmetric condition. Is it possible? Yes. Symmetric condition. Let us check. So according to the symmetric condition, what does it says? It says that for the elements of A comma B belongs to A means obviously B comma A also belongs to A. Right. In symmetric condition, what you take any kind of random elements. For example, if I take 3 minus 2. Why I have to minus? Because of this condition. So 3 minus 2 means it is giving the value 1. 1 can be multiple by 4. Yes, it is possible. So according to this, so we can say that so mod of A minus B is equal to multiple of 4 which is belonging to R means then we can also say that mod of B minus A also is also multiple of 4 which belongs to R. So hence it is symmetric. Hence it is symmetric. Next, what does the transitive says? In the transitive condition, so transitive condition says A comma B should belongs to R means obviously B comma C should belongs to R, then A comma C also should be able to belongs to R. Let us take, let A is equal to 1, B is equal to 3 and C equals to 8. Let us take a random elements here. So according to this, what does it says? Let us check. So mod of A minus B which is equals to mod of 1 minus 3 which is equals to 2. It is a multiple of 4. Next, again mod of b minus c, that is, what is the value of 3 minus 8, which is equals to 5, multiple of 4. Yes, again mod of a minus c, which is equals to 1 minus 8, which is also 7, multiple of 4. So these all belongs to R. So according to this, hence it is a transitive. Hence it is a transitive condition. Hence it is transitive. So this proves the values of reflexive, symmetric and transitive. If all the three conditions are satisfied, means obviously it is an equivalence relation. So according to this, we have missed a small thing here. So if it is a multiple of 4 means, so what are the sets will be available for the given set A, multiple of 4? That is, 1 is available, again 5 is available and 9 is available. How can I say it is a 9? Very simple. If I deduct with the elements of, for example, let us take is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it should be a multiple of 4. So when you deduct the values of a minus b, it should be an multiple of 4. Means if I deduct 1 minus 5, it will give the value 4. 4 is a multiple of 4? Yes. Again, for 1 and 4 is possible. So 1 is possible. If I take 5 is also possible, and if I take 9, so 9 minus 1 means it gives the value 8. So 1 minus 9 is equal to 8. So therefore we have the set of 1, 5 and 9. So these are the elements which satisfies the whole equation. So this is the one set which has been finished. So there is a homework. In the same way you need to do for the second element, that is second question. What does it say? R is equal to a comma b. For every a is equals to b means obviously if I put 1 means 1 will be occurred. So it is a multiple of 4. So therefore 1 is equal to 1, 2 is equal to 2. All the sets of a is also possible. So therefore hence it is reflexive is possible. If I put a is equal to 1 means b is equal to some other elements means if I deduct those two elements also, symmetric also possibility is there, and as well as symmetric. For all the elements, the given set of 1 will be your set of elements. So prove it for question number 2.